For thousands of years, human beings have been trying to overcome their limitations. We built tools to make our bodies stronger. The wheel allowed us to travel farther. Writing allowed us to preserve knowledge. Computers allowed us to process information faster than ever before. Every major technology in history has extended a part of what humans can do. But one limitation has remained: the human brain. The brain is the most powerful biological computer we know. It creates thoughts, stores memories, controls movement, and allows humans to understand the world around them. But despite centuries of progress, we still communicate with machines in the same basic way. We use keyboards, touch screens, voice commands. We tell machines what we want through physical actions. But what if that changed? What if humans could communicate with machines directly through the brain? This is the idea behind brain-computer interfaces, a technology designed to create a direct connection between the human brain and computers. For some people, this technology represents something life-changing. A person who cannot move could potentially control a device using only their thoughts. A person who lost communication ability could have a new way to interact with the world. But for others, brain-computer interfaces represent something much bigger. Not only repairing human abilities, but expanding them. This is where Neuralink enters the story. Founded in 2016, Neuralink was created with an ambitious goal: to build a bridge between the human brain and artificial intelligence. The company became one of the most ambitious technology projects in the world. But Neuralink is not only about a brain implant. It represents a much bigger question. What happens when technology no longer surrounds humans, but becomes part of them? To understand Neuralink, we first need to understand the problem it is trying to solve. To understand Neuralink, we first need to understand the problem it was created to solve. The human brain is constantly sending signals. Every movement, every decision, every action begins as electrical activity inside the brain. When you move your hand, your brain sends a signal. When you speak, your brain creates the instructions that control your voice. The brain is already communicating with the body. The problem is, what happens when that connection is damaged? Millions of people around the world live with conditions that affect movement and communication. Spinal cord injuries, neurological diseases, loss of motor function. The brain may still work. The intention may still exist. But the message can no longer reach the body. This creates one of the biggest challenges in modern medicine. How can we restore the connection between the brain and the outside world? Brain-computer interfaces were created to answer this question. Instead of sending signals from the brain to muscles, a computer could interpret those signals directly. The goal is not to read thoughts like a science fiction movie. The goal is to understand intention. If someone wants to move a cursor, the brain creates a pattern. If someone wants to control a device, the brain creates another pattern. Neuralink's mission is to capture those signals and translate them into useful actions. This idea is especially important for people who have lost physical abilities. A person who cannot move their arms could potentially control a computer. A person who cannot communicate could potentially regain a way to interact. For this reason, the first promise of Neuralink is not creating superhumans. It is giving people back abilities they lost. But this is only the beginning of the story. Because once humans learn how to repair the connection between brains and machines, another question appears. Can that same technology go beyond repairing humans and begin enhancing them? The human brain is incredibly powerful. But understanding the brain has always been one of the greatest challenges in science. Inside the brain, billions of neurons communicate through electrical signals. These signals create everything we experience: movement, memory, language, thought. The challenge is simple to describe, but extremely difficult to solve. How can we translate the language of the brain into something a computer can understand? This is the problem Neuralink is trying to solve. At the center of Neuralink's technology is a small device called the N1 implant. A tiny computer designed to record activity from neurons inside the brain. The implant connects to extremely thin threads called neural threads. These threads are much thinner than a human hair. Their purpose is to capture electrical signals from specific areas of the brain. But placing these threads inside the brain is not simple. The human brain is delicate. Even tiny movements can create enormous challenges. This is why Neuralink developed a specialized surgical robot. The robot is designed to place extremely small threads with high precision. The goal is not simply inserting hardware into the brain. The real challenge begins after implantation. The brain does not communicate using words. It communicates through patterns of electrical activity. A computer does not naturally understand those patterns. This is where artificial intelligence becomes essential. AI models analyze the signals collected from the brain and learn to associate those patterns with intended actions. For example, a person may imagine moving a cursor. The brain creates a unique signal pattern. Neuralink attempts to recognize that pattern and convert it into a command. It is not reading a person's thoughts. It is interpreting intention. This distinction is important because the future of brain-computer interfaces does not depend on controlling the mind. It depends on creating a new form of communication. A communication channel between humans and machines. For decades, connecting the human brain directly to a computer sounded like science fiction. Scientists imagined it. Engineers researched it. But turning the idea into reality was one of the greatest challenges in technology. Neuralink entered this field with an ambitious goal. Not just to study the brain, but to create a practical connection between humans and machines. Before human testing began, Neuralink spent years developing its technology through research and experiments. The company tested whether brain signals could be captured and translated into computer commands. These experiments demonstrated something important. The brain could communicate with machines. But the biggest moment came when Neuralink moved from experiments to human trials. In 2024, Neuralink announced its first human implant. The goal was not to create a human-machine hybrid. The goal was much more practical. Allow a person with limited physical movement to interact with technology using brain signals. The early results showed a significant milestone. A person was able to control a computer cursor using only brain activity. A simple action, but a historic moment. For most people, moving a cursor is effortless. A hand moves, a mouse clicks, a command is sent. But for someone who has lost physical control, that simple action represents independence. This is where Neuralink's medical potential becomes clear. The technology could eventually help people communicate, control devices, and interact with the world in new ways. But every breakthrough creates a new question. If we can restore human abilities, what happens when we try to enhance them? Because Neuralink's future may not only be about helping humans recover what they lost. It may be about changing what humans are capable of becoming. The first purpose of Neuralink is clear: help people who have lost abilities. For someone who cannot move, a brain-computer interface could create a new connection to the outside world. For someone who cannot communicate, it could provide a new way to express thoughts and intentions. But every technology that repairs human limitations eventually creates another possibility. What if the technology could go beyond repair? What if the brain-computer interface was not only for people who lost abilities, but for people who want to gain new ones? This is where the conversation around Neuralink becomes much bigger. Because human history has always been about extending our capabilities. We created glasses to improve vision. We created machines to increase physical strength. We created computers to expand our ability to calculate and process information. Neuralink asks a much deeper question. What happens when technology can directly interact with intelligence itself? In the future, brain-computer interfaces could potentially change how humans interact with digital systems. Instead of typing, instead of touching a screen, instead of speaking commands, humans may communicate with machines through intention. This possibility creates enormous opportunities. Learning could change. Communication could change. The relationship between humans and artificial intelligence could change. But it also creates difficult questions. Who controls the data created by the brain? How do we protect human privacy when our thoughts become connected to technology? And if some people can enhance their abilities, while others cannot, will technology create a new form of inequality? These questions are not only about Neuralink. They are about the future relationship between humans and technology. Because the biggest change may not be that machines become smarter. It may be that humans and machines begin to become connected. And that raises the biggest question of all. If technology becomes part of our minds, what does it mean to be human? To understand why Neuralink matters, we need to look beyond the brain. Because Neuralink is not an isolated experiment. It is part of a much larger vision about the future of humanity. For decades, humans have been limited by three major boundaries: how we move, where we can go, and what we are capable of becoming. Tesla, SpaceX, and Neuralink each focus on one of these boundaries. Tesla began by changing transportation. Electric vehicles challenged the idea that cars had to depend on fossil fuels. Autonomous driving pushed the idea that machines could understand and navigate the physical world. Tesla is not only building cars. It is building a new relationship between humans and intelligent machines. SpaceX focuses on a different limitation. Humanity has always lived on one planet. SpaceX's long-term vision is to make humans capable of becoming a multi-planetary species, to expand where humanity can exist. But Neuralink focuses on the most personal boundary: the human mind itself. If Tesla connects humans with intelligent machines in the physical world, and SpaceX expands where humans can travel, Neuralink explores how humans can communicate and interact with intelligence itself. Together, these companies represent three different directions of technological expansion: the outside world, the space beyond Earth, and the inside world of the human brain. This is why Neuralink attracts so much attention. The company is not only developing a medical device, it is exploring one of the final frontiers of human technology. Of course, a vision this ambitious comes with enormous challenges. Technical challenges, ethical questions, and uncertainty about the future. But whether Neuralink succeeds or fails, it represents an important question. Are humans creating technology? Or is technology beginning to reshape humans? The biggest question about Neuralink is not whether a brain implant can control a computer. The bigger question is, what happens if humans can communicate with intelligence itself? For most of human history, our abilities were limited by biology. We could only learn as fast as our brains allowed. We could only communicate as quickly as our bodies could express. Technology changed this relationship. Books expanded memory. Computers expanded calculation. The internet expanded access to information. But all of these technologies still exist outside the human brain. Neuralink represents a different possibility. A future where the connection between humans and technology becomes much more direct. Imagine a world where communication does not depend only on speech, where people with disabilities can interact more naturally, where humans can interact with artificial intelligence in new ways. These possibilities are exciting, but they also create difficult questions. If technology can access signals from the brain, who controls that information? If technology can enhance human abilities, who decides how it should be used? Every major technology creates new opportunities, but it also creates new responsibilities. The internet connected billions of people, but it also created new challenges around privacy and control. Artificial intelligence can increase human productivity, but it also raises questions about the future of work. Neuralink may create the same type of transformation, but at a much deeper level. Because this time, the technology is not only changing what humans use, it may change how humans interact with the world itself. Whether Neuralink becomes a medical breakthrough, a new computing platform, or something completely unexpected, one thing is clear: the next technological revolution may not happen around us. It may happen inside us. Throughout history, the greatest technological revolutions have changed more than industries. They have changed the way humans live. The internet changed how we communicate. Artificial intelligence changed how we work. Neuralink asks whether technology could change something even deeper: the way humans interact with intelligence itself. This is why Neuralink has attracted so much attention. Not simply because of a brain implant, but because it represents a possible transition. From humans using machines to humans working together with machines. This vision connects Neuralink with Elon Musk's other companies. Tesla focuses on intelligent machines on Earth. SpaceX focuses on expanding where humanity can exist. And Neuralink focuses on expanding what humans can become. Together, they represent three different directions of the same question. How can technology remove the limits of humanity? But every powerful technology comes with uncertainty. A faster computer, a smarter machine, a direct connection between the brain and artificial intelligence. Each breakthrough creates new possibilities and new responsibilities. The future of Neuralink will not only depend on engineering, it will depend on how society chooses to use it. Because the biggest question is not whether machines can become more powerful. The bigger question is how humans will change when machines become part of us. Neuralink may succeed. It may fail. It may become something completely different from what people imagine today. But it has already started an important conversation. The next frontier of technology may not be outside the human body. It may be inside the human mind.